In this anaerobic digestion types segment, we are going to discuss about different types of anaerobic digestion technologies, and that will include conventional and low rate anaerobic digestion as well as advanced and high rate anaerobic digestion. So let's start. Type selection considerations. There are many different anaerobic digestion systems available in the markets that vary in process configurations and operating conditions. The design considerations and operating conditions of these treatment trains may be suitable for particular types of feedstock or feedstocks mix, but may not be applicable or economical for others. That is why digester type and technology should be selected based on the following criteria. First of all, intended feedstocks characteristics and the amount to be treated. Then, desired product output and end use, like resource recovery options and market demands, etc. And of course, the overall process economy, considering energy efficiency and return of investment period. Let's start with conventional and low rate anaerobic digestion types. Covered anaerobic lagoon. It is generally in ground earthen or lined lagoon that is covered with impermeable gas collecting cover like synthetic membrane. Inside content can be heated or mixed, but are not typically done due to large volume. System can handle a wide range of waste, including manure and wastewater. Usually the system has the following properties. It can handle a total chemical oxygen demand of less than 2 kg per meter cube day. The percent solids recommended are 0.05 to 3% range. The HRT of the system is 40 to 60 days, and the system is not optimal for co-digestion. Plug flow anaerobic digester. It is one of the least expensive and simplest form of anaerobic digestion system. Usually it is a long, narrow tank, typically heated and below ground, with impermeable gas collecting cover. The waste enters on one side of the reactor and exits on the other. Plug flow systems are subject to stratification as the sands and silts settle to the bottom. Although modified plug flow system can use vertical mixing techniques. Usually the system has the following properties. The percent solids vary from 11 to 13%, HRT is greater than 15 days, and the system is not optimal for co-digestion. Complete mixed digester. It is one of the most common anaerobic digestion systems used by many sewage and industrial treatment plants. It is usually an above or below ground, heated or unheated tank with gas collecting option. Content get mixed via mechanical mixer, gas or pumps, and most complete mixed digester works in mesophilic phase, but some of them work in thermophilic range as well. Usually the system has the following properties. The percent solid it can handle varies from 3 to 10%. HRT is greater than 15 days, and the system can be used for co-digestion. Let's move to advanced and high rate anaerobic digestion. Let's start with upflow anaerobic sludge blanket, UASB. This is a high rate system where the influent is added continuously to the bottom of the reactor. There are dense granular anaerobic biomass at the bottom of above ground heated vertical tanks. These systems are best suited for consistent homogeneous waste stream, and usually the system has following properties. Reactor height can vary from 5 to 20 meter. Design COD loading can vary from 5 to 20 kg per meter cube day. Recommended percent solid usually less than 3%. HRT is typically less than 5 days. And the system is suitable for co-digestion. Fixed flame or attached media digester or anaerobic filters. They are usually above ground heated tank systems that contain attached or supported media like plastic or wood chips on which anaerobic biomass can grow. With the help of fixed flame attached media, a large biomass and long SRT can be achieved in the system. The system can run both upflow or downflow configuration. Usually the system has the following properties. Designed COD load can vary from 5 to 20 kg per meter cube per day, and recommended percent solids varies from 1 to 5%. HRT typically 5 days or less, and yes, the system is suitable for co-digestion. And this is how one of the systems look like. Anaerobic contact process. The contact reactor is a high-rate process that retains suspended bacterial biomass in a completely mixed reactor. The system contains a solid-liquid separator, like a settling tank, solid thickener, centrifuge, etc., and return the solid back to the influent. Usually the system has the following properties, that is longer SRT than HRT because it recycles the solid part, decreased digester volume and increased biogas production. Design COD loading can vary from 2 to 5 kg per meter cube day, and recommended solids vary less than 2.5%, especially when gravity separation is used for solid liquid separation. Anaerobic sequencing batch reactor, or ASBR. It is typically an above ground heated tank reactor with gas collection option. Dilute and liquid waste like manure is added and removed from the reactor in batches. Reaction and solid liquid separation take place in the same vessel, and this is done through 4 steps of ASBR cycle. Fill, react, settle and decant. We can see here first the reactor is getting filled, and in this step the reaction takes place, and then certain time is allowed for settlement, and then when the settlement occurs the effluent or supernatant take out from the system, and that complete one batch, and the next batch will continue with the same steps. Usually the system has the following properties. The recommended solids varies from 2.5 to 8%, and HRT typically 5 days or less, and yes, the system is suitable for co-digestion. Anaerobic membrane bioreactor, or NMBR. This system consists of a complete mixed reactor with suspended anaerobic biomass and a membrane unit for solid liquid separation. The system employs solid recycling for achieving long SRT with a short HRT. No suspended solid in final effluent significantly improves the effluent quality and reuse option. Usually, the system has following properties. Design COD loading can vary from 5 to 15 kg per meter cube per day. Let's move to multi-staged or phased anaerobic digesters. In a multi-stage anaerobic digestion, multiple reactors, usually 2 of them, are designed in series to optimize the process and enhance gas production. By introducing staged operation, facilities can optimize each stage of process reaction for the organics breakdown and enhance more organics destruction. Although multi-stage digestion process is more complex and require more capital cost, some of its benefits are as follows. Enhanced gas production, more volume reduction through VS destruction, better odor control, can configure to reduce foaming problem, and short circuit prevention via multiple reactors. So some multi-stage and phased digester are going to be discussed in the following slides. First one is staged mesophilic digestion. Literature findings indicated that two-stage mesophilic digestion may produce more stable, less odorous biosolids that are easier for dewatering. Two anaerobic digester coupled in series as primary and secondary digester is not uncommon, but there is not much information available regarding two heated well-mixed digester in series. Acid-gas or AG-phase digestion. In a two-stage acid-gas phase digestion, the acid-forming stage, that is the first step of anaerobic digestion process, hydrolysis and volatile acid fermentation, are physically separated from the methane gas forming stage by dedicating a digester designed and optimized for each of these two stages. The first phase is conducted at an acidic pH 6 or less, and at a lower acidity favorable for volatile acid formation. The second digester is operated at a neutral pH and longer acidity to suit the need of methanogenic bacteria and maximize methane gas production. So here we can see in the image that we have a mesophilic stage where acidity is very low, and it's the acid phase, and the next stage is a gas phase stage where acidity is longer for methane formers, and we can have a mesophilic stage followed by a mesophilic or thermophilic reactor, or we can have a thermophilic reactor followed by a mesophilic or thermophilic reactor as well. Then we have staged thermophilic digestion. In staged thermophilic digestion, a large digester is followed by one or more smaller digester to prevent pathogen circuiting and achieve a class A biosolid. So class A biosolid is a very higher priority biosolid. Class A biosolid definition is a biosolid that contains no detectable levels of pathogens, and also class A biosolid meet strict vector attraction reduction requirements and low levels of metal contents. One such example of staged thermophilic digestion is Annacis Island wastewater treatment plant in Vancouver, BC, Canada, where first stage is followed by 3 subsequent stages. Then we have temperature-phased anaerobic digestion, or TPAD. TPAD incorporates both thermophilic and mesophilic reactor, as you can see in the image. And they are connected in series to take advantage of the higher digestion rate of thermophilic digestion as well as the higher stability of the mesophilic digestion. Overall, the TPAD process has greater volatile suspended solid destruction and gas production ability. It is reported that VSS destruction efficiencies of the TPAD process are 15 to 25% greater than the single-stage mesophilic digestion process. The TPAD process is also reported to have better shock absorbing capacity, lesser foaming issues, and ability to produce a class A biosolid. Let's move to the latest addition, that is solid or high solid state, or dry anaerobic digesters. So these are the digesters that can handle higher solid content, greater than 15% of solid content. So dry digestions are suitable to handle waste at high solid loadings, as well as ligocellulosic biomass such as silages of corn, grass, rye, etc. Also waste like shaded MSW, residential food waste along with lawn and yard waste, etc. These types of digesters are usually produce end products with higher solid content, consume less energy for heating, and require longer retention time and additional equipment for mixing and material flow on the output side. The high solid anaerobic digestion that is designed for pumpable high solid feed like wet food waste slurries, usually 15 to 35% solid content, are further known as wet high solid or dry pumpable digestion. Let's discuss some commercially available high solid digester types. One of them is Glycone high solid anaerobic digestion. So Glycone is a two-stage dry wet anaerobic digestion process and operates in batch mode. The Harvest Energy Garden, located in Richmond, BC, Canada, is based on this technology and is owned and operated by Harvest Power Canada Limited. This is the first industrial-scale high-solid anaerobic digestion plant in Canada and is also one of the largest plants in North America. The plant processes approximately 30,000 tons per annum of combined food waste and yard waste and produces approximately 770 kilowatt of electrical energy. And this is an image of the system. The next type is biofarm dry fermentation system. The biofarm is a batch type dry anaerobic digestion system that operates in the mesophilic temperature range. It is well suited for solid waste materials with a solid content of 25 to 35%. The biofarm dry fermentation system is suitable for municipal organic waste including yard waste. Biofarm plants consist of multiple concrete garage style, as you can see in the image. It consists of multiple concrete garage style digester that can be gas tight. Front end loaders load feedstock into those chambers where they get digested for an average of 28 days. The digesters are heated through inward radiant heat and through percolate. Inside the digester, feedstocks remain still. Compogas anaerobic digestion. The compogas is a patented dry anaerobic digestion process. The process uses a continuously feed horizontal flat flow digester. The feed system automatically conveys the feed to the digester and process water is added inside the digester to maintain the optimum ratio. The digester has a low speed agitator inside. The temperature of the process is thermophilic, operating at 53 to 55 degrees centigrade. The average feedstock moisture content is around 75% and the retention time inside the digester is approximately 14 days. So here is an image of the compogas process. Dranko anaerobic digestion technology. The Dranko anaerobic digestion technology by organic waste system is a patented process as well. Dranko digestion is often applied to mixed waste or residential household waste or organic fraction of municipal solid waste, source separated organics, yard and food waste. The plant can operate at dry matter content inside the digester of up to 40%. The three main characteristics of Dranko are its vertical design, high solid concentration, that is 20 to 35%, and the absence of mixing inside the digester. With this, I close the anaerobic digestion type segment and we'll move to the next one, that is about biogas handling, cleaning and upgrade. We'll see you there.